Hello everyone. Today we are going to study heat transfer as a subject in third year engineering mechanical. My name is Naveed. Let's begin. Heat transfer is actually the subject which deals with the understanding of a force and energy which flows through the mediums and sometimes without mediums because of the temperature difference. So here the basic definition of heat transfer is the energy in transition because of the temperature difference, and obviously it flows from higher temperature to the lower temperature. In studying heat transfer, we have four specific objectives in front of us. First of all, we are going to model basic heat transfer processes and identify modes of heat transfer so that we can design and predict the heat exchanger performances, which actually is the product of this study, during which we are going to recognize basic convective heat transfer and apply appropriate methods for quantifying convection and its analysis in the form of mathematical solutions and governing equations. Also, we are going to determine the radiation heat transfer, which is observed on many places, specifically to the life force on Earth. We'll come to that later. During this study, first of all, let's make a clear difference between thermodynamics and heat transfer. Thermodynamics is a science which deals with finding out the properties of a substance at rest, that to be in equilibrium. And during the processes of such equilibrium states, we don't know anything about the substance. We cannot predict any properties during the process. So ultimately, we have to wait for the substance to reach the stable equilibrium position, and then we are going to find out its properties. While the heat transfer study actually permits one to find out the temperature and other properties at various sections throughout the substance at any point and also at any time. So these two advantages heat transfer studies have over thermodynamics, that it does not require any equilibrium state to reach. During continuous process also we can find out the properties in respect of distances and in respect of time as well. Let's study the modes of heat transfer. Apart from these conduction, convection, radiation, one more mode of heat transfer is present called advection. That is the heat transfer by means of material transfer. That is, we are going to heat up some material, then transfer it and take our heat at another place, transfer to some other body. That is advection, which is not covered in the syllabus here. So first of all, we'll study what is the conduction. I'll give you an example. Try considering this fire, a bonfire. If you heat up a metal rod over that fire, one end of that metal rod will get heated and the heat will travel through the cross section of that rod, feeling the hotness or the warmth of that fire at the other end. That is because of conduction. Conduction is governed by two mechanisms, lattice vibration and free electron flow. Second one is convection. See, the air above this bonfire is heated up, and because of the density difference it is rising up, and the person above it can feel the heat because of that air which has absorbed the energy. This is convection. And finally, radiation. If there is no material medium travel from the heat source, even then the electromagnetic waves can reach to the distances where the person can feel the heat by means of radiation. Let's consider one more example. Boiling of water in a pan. In such example, the coil heats the vessel and the vessel gets heated and its handles as well. This is because of conduction, whereas the water inside the pan gets heated because of convection, and electromagnetic rays continuously leave the coil. That is radiation. One more most important example of radiation is sun rays coming to earth by means of radiation. This gives us clear understanding that apart from conduction and convection, radiation does not require any materialistic medium for the electromagnetic waves to pass and transfer the heat. This is the advantage of radiation, which conduction and convection does not have, because they both require material medium. After studying the modes of heat transfer, we have to find out the governing equations which deal with the numerical treatments associated with the physical systems governed by conduction, convection, and radiation. For that, I have given some little examples here. Like conduction is the one where we have heat source in direct contact with some physical body, specifically metal, and all those bodies which feel warm because of the touch are uh, tra transferring the heat by means of conduction, whereas convection involves the flow of air or flow of water or any kind of fluid, because the solid to liquid interaction is visible uh, uh, in convection, whereas the radiation does not require any materialistic medium. The radiation heat transfer follows the electromagnetic wave path, same as light. All these information which we are going to collect through the heat transfer studies are going to be utilized to design heat exchanger equipments. The effect of various physical phenomena on analysis and design of heat exchanger equipments are very important in terms of heat transfer. In this simple example, you can see the hot fluid is coming inside the vessel in the form of tube marked as red, and it is leaving after cooling down, and the cooling fluid also enters, shown as blue, and gets hotter after leaving the heat exchanger. This performance has to be evaluated by mathematical equations. After all, this complete course has been assessment strategy mentioned in the table. The students will have to attempt class test and term work to get 45 marks, and theory exam for 80 marks, and final practical Viva exam of 25 marks. That's all. Thank you.